Alright, let's consider the geometric sequence that begins with 20, 10, 5, 5 halves, and so on. In part A, what we want to do is identify a few of the initial terms, like the first term is obviously 20, and the fourth term is also on the list. There's A1, A2, A3, and A4, so A4 is 5 halves. But then it asks for the fifth term and the sixth term. Now, before we can really find those, we're really going to need to know what the common ratio is. And that's going to be the number that we multiply each term by to get from one term to the next. So what do we multiply 20 by to turn it into 10? And what do I multiply 10 by to turn it into 5? And it's pretty easy to see that I can take 10 divided by 20 and see that I'm multiplying every term by a half. So to get the fifth term, I'm going to go back to the fourth term and multiply it by a half. That'll give me 5/4. Then to get the sixth term, I'm going to multiply that by a half, which will give me 5/8. Next, we can find an expression for the nth term, which would be any term in the sequence. And for a geometric sequence, our kind of general formula is the first term times the common ratio to the n minus 1th power. So in this instance, our first term is 20, and we're going to multiply that by the common ratio, which we said was 1/2, and then raise it to the n minus 1th power. And that's all we have to do. Once we have that expression, it's easy to find out any term in the sequence. So in part C, I ask you for the 10th term. And we'll just plug that into the formula we just came up with, 20 times our common ratio, 1/2, to the 10 minus 1th power, or 10 minus 1 is 9. Now it's just a matter of grabbing a calculator and calculating that out. And you should get about 0.039. In part D, we're asked to find the sum of the first 10 terms. So remember our formula for the sum of a geometric sequence, and that is the first term minus first term times the common ratio to the nth power over 1 minus r. So in this case, our first term is 20 minus 20. And in the denominator, we'll have 1 minus. And both of these parentheses are going to be our common ratio, that 1/2. And then the power of the 1/2 is the same as the number of terms that we have, so 10. Now it's just a matter of grabbing the calculator and calculating that out. And we get the 39.960. In part E, we're going to use sigma notation to find the sum from n equals 1 to infinity of 20 times 1/2 to the n minus 1th power. And that expression should be familiar because that's what we came up with for the nth term of this geometric sequence. That means we're going to be dealing with an infinite geometric series where the common ratio is less than 1, which is great news because that means it's going to be convergent. Before we even get started on finding that sum, we're going to still do the same first step that we always do, and that is list out the first few terms of this expression. So first we'll plug 1 in for n, and 1 minus 1 is 0. Anything to the 0 power is 1, and 20 minus 1 is 20. The next term, well, we already know it. It's all sitting right up here. It's going to be 10, and then it's going to be 5, and dot, dot, dot. I know that I put a blank down here, but there's really nothing that we can put there because it's going to go to infinity. So we know it's an infinite geometric series. We know that the common ratio is less than 1, so we can use our infinite geometric formula, which is a1 over 1 minus r. So quickly grab the first term over 1 minus the common ratio, and that'll be 20 over 1 minus a half is a half. 20 divided by a half, same as multiplying by 2, and there's our infinite sum of 40.